So I'm going to go ahead and go through the slides on this one, simply because the slides are pretty good. And if you're having trouble with any of the other sorting algorithms, just go ahead and reconsider the slides. But I want to get through the slides so we can see how this algorithm works. So Quicksort, it's a pretty old algorithm. And this is just simply talking about what we've already discussed. Quicksort selects a specific value, the pivot, and then we rearrange the array or the list into two separate parts. This is called partitioning. Technically, it's three. Right? You've got the pivot itself counting M1, and then you've got the left subarray where all the stuff is less than the pivot, and all the stuff is greater than the pivot. And then we put the pivot between the two subarrays. So we repeat this until it's sorted. So ideally, again, this works like this. We're going to just, again, select the first element of a list or array as pivot. That should be in the middle. And then we put all the stuff that's less than the pivot on the left, all the stuff that's greater on the right. And this is ideally how it works. And then we just recursively do that. And then we would keep recursively doing that. Now, I'm skipping through this very quickly because that's actually not the way it's going to work. I mean, ideally that's how it works, but there's a lot that goes on. Right? So this is the very kind of simple algorithm. We let first and last be the endpoints of the array being sorted. So, right, this would be first here, and this would be last here. The index of the pivot after we do partition is pivot. So if we have a range of stuff to sort, in other words, first is less than last, we have a range of stuff to sort, so then what we need to do is we need to partition all the elements in the subarray so that pivot is in the correct place, so that all the stuff less than it is to its left, all the stuff that's greater than it is to the right. And then we recursively quicksort everything before the pivot and everything after the pivot. All right? So the idea here is that if the pivot is a random value, then statistically half the items of the subarray will be less than it, and half will be greater, right? Half the stuff will go to the left, half the stuff will go to the right, if we've got a pretty big array and we actually choose a random value. And that means we'll get log n level recursions, and at every recursion level, we will move every element into its correct position, n moves. So there's each level we're moving n items, and then there's going to be log n levels on average, so that's just like merge sort. However, you might not get 50-50, you might get 40-60, you might get 30-70, or you might get everything goes to one side. Right? The analysis is a bit difficult, but it's going to be close to n log n, unless we get very bad partitioning behavior. And we'll talk about how do we avoid that. And an example of what that might be is that if we always choose the first element as our pivot and the array, and we are passed a sorted array or a completely reversed array, in which case that will be of n squared. So how does pivot work? So actually pretty much pretty much all this algorithm is fairly straightforward except for partition. That is the magic bit, right? Quick sorting the left half, quick sorting the right half. Doesn't really matter. The pivot of how do we take this pivot and move everything that's less than it to the left, everything that's greater than it to the right, is actually the magic bit. Now you might go, wait, that was easy. I just saw you do it with all those circles that on your desk. And I'm like, well, yes, but I wasn't doing it in place. I was, creating new lists, moving stuff around willy-nilly, right? But we need to do this in place to get this working. So, all right, so how does this work then? Well, for simplicity's sake, we just start with the first element, right? We choose 44 as our pivot in this example because it's the first element, just for simplicity's sake. So we're going to go ahead and color code. Everything that's less than the pivot will be blue. Everything will be light purple if it's greater. So let's go ahead, boom, right? Everything's less than is one color. Everything's greater than another color. Honestly, I think they all look like different kinds of purple, but whatever. They're at least color-coded now. All right, so now to do this, what we are going to do is that we are going to have 4 variables. We're going to have our first and last, right? First and last. And then we're going to have something called up, and then we're going to have something called down. those are the 4 variables we use. And essentially what we're going to do is that we are going to go up the array searching for the, so this is, how do we do partitioning, by the way? How do we do partitioning? How does partitioning work, right? These 4 variables we have. And the big thing is we have this variable called up, which starts at first and goes up through the array until it finds the first item that is bigger than the pivot. Okay, once we do that, we then then we use the other value, which is called down. And we search down through the array to find the first value that's smaller than the pivot. Okay, everybody got that so far, right? So we are discussing how do we do the partition. How do we do the partitioning part of Quicksort, where we basically have this middle item over, we got to get this item in the middle eventually, right? So we need to put all the items that are less than together, all the items that are greater than together. So we search up through this array until we find the first item that's greater than the pivot. Then we search down through the array until we find the first item smaller. Once that is done, if up is to the left of down, we swap them. Ooh, that's interesting. And then we just keep continuing. Let's go ahead and start, and we look up for the first value that is greater than the pivot. So that's going to be 55. That is the first value that is greater than our pivot. Then we're going to search down for the first value that is smaller than the pivot. Up and down. So now we swap those values. Make sense? And look what has just happened by doing that, right? We are searching up for the first value that we can find that is bigger, down for the first time that is smaller, and by doing that twice, we have successfully basically split this array into pivot, all the items less than pivot, all the items greater than pivot. That's not exactly what we wanted, but it's pretty darn close. So now let's just go ahead and see how this works. So again, let's get to our terminating condition. We search up for the first item that is bigger than our array. Now let's go ahead and search down for this first item that is smaller than our pivot. Okay, we found them. And remember I was saying initially, we got to make sure that up is to the left of down. Well, they just crossed. Down is now to the left of up. Down has passed up. Up has passed down. They've crossed. That's how we know we've done. That we're done. That we have basically sectioned everything into 2 sections. So in this case, we don't do we don't exchange up and down. Instead, what we do is that we exchange down and pivot. Boom, like that. And now look what we have. We've got all the items less than, all the items greater than, and we've got our pivot square in the middle of them. So that's how partition works. And partition is the magic of how Quicksort works. So then, now that we've got this done, we quicksort the left and then we quicksort the right. So we return the index of the pivot, and then we just do quicksort on those left half and the right half. And there's the algorithm for you if you want to look at it, pause the page. Right? And then what we're going to go ahead and do is that I'm going to go ahead in the next video is show you how to do this with the items that I have on my desk.